This is an empirical formula question with a slight bit of a difference. So in most ways it looks very much like a normal empirical formula question because I've been given the elements that the compound contains and I've been told the percentages by mass of each of them. The only difference is instead of saying find the empirical formula, it says find the molecular formula, and it gives me the RFM of the compound. Now sometimes it'll ask for the empirical formula first, and then part B of the question will be if the RFM is 228, what is the molecular formula? So actually, because I've got percentages, the first thing I'm going to do is just work out the empirical formula, which remember is the simplest whole number ratio of the elements in the compound. So I'm going to set it out in a little table across the page because that's much clearer than trying to do my calculations alongside in a line. I much prefer it to have my N, my H, my S and my O all along each other like this, separate so I can see what's going on, have them all above each other. So what do I know? Well, I know my percentage, which I'm going to put in brackets grams, because basically I can assume I've got 100 grams and that in that 100 grams I've got 12.28 grams of nitrogen, 3.51 grams of hydrogen, 28.07 of sulfur and 56.14 of oxygen. Okay, so far so good. I'm then going to go to the periodic table and write down the relative atomic masses of each element. So nitrogen is 14, hydrogen is 1, sulfur is 32 and oxygen is 16. So now I can do my moles, which is just mass in grams divided by relative atomic mass. And there's going to be possibly some messy numbers, but let's see what we get. So 12.28 divided by 14 gets me 0.877. I'm going to do 3 decimal places there, just so I don't lose anything along the way. I don't want to round up too soon. At the same time, I don't really need like sort of 15 decimal places. 3.51 divided by 1 is pretty easy. And then we have 28.07 divided by 32, which also gives me 0.877. This will often happen that I'll get 2 of the same numbers coming up. That's a good sign. It shows that I'm probably doing my maths right. 56.14 divided by 16, and that gives me 3.508, which I'm going to round up to 3.51, and you can see that that's the same as my hydrogen. So my hydrogen and my oxygen have got the same amount in each. Okay, so far I've got my moles, sort of, but they're messy moles. And an empirical formula is the simplest. So empirical formula is the simplest whole number ratio of elements. So we're going to try and get it to the whole numbers. That's the thing we're aiming for. These are not whole numbers. I've got 8.77, 3.51. So we do my divide by the smallest number. The smallest number of moles is 0.877. So if I divide that by itself, I get 1. If I divide that by itself, I get 1. If I take my 3.51 divided by 0.877, then I get a number which is essentially 4 to the number of decimal places I'm going. So that tells me I have 4 of those and 4 of those. Okay, that's my empirical formula bit done. All I need to do is show it's N, 1 of those, 4 of those, 1 S and 4 O's. So far so good. That's my empirical formula. That's really probably like most of the marks in the question. But what I haven't done, I've used all of that. What I haven't done, I haven't used this, and I haven't done this thing called molecular formula. So What I need to know is, empirical to molecular is really just, this is the simplest whole number ratio. Okay, in the same way that, if we do an example up here, hydrogen peroxide has the formula H2O2. That's the real molecular formula. That is how many atoms of hydrogen and oxygen there are in a molecule of hydrogen peroxide. But that's not the simplest ratio. I could cancel that down because both of these are 2s, and I could say that HO is the empirical formula. So the question's saying, I've worked out this is definitely that there is 1 nitrogen to every 4 hydrogens, to every 1 sulfur, to every 4 oxygens. But what I don't know is how many there really are in the molecule, because it could be N2H8S2O8, or it could be N3H12S3O12. So how I work that out is I've been given the RFM of the real molecule. The formula mass tells me that's what the real formula is. So what I need to do is work out how many times that, the mass of this, fits into this mass here. So going back, here are my RAMs up here. So if I want to work out the RFM of this, it's going to be 14 for my 1 nitrogen, plus 4, because I've got 4 times 1, plus 32, plus 16 times 4 for my 4 oxygens. So I'm going to work all that out, and I get 114 as my RFM for that molecule there. If I go back to the RFM I'm given an RFM, it was 228, and so what that tells me is that is 2 times 114. So that means that rather than the real formula being NH4SO4, the real formula, the molecular formula, is N2H8S2O8. That's a very complicated formula, but it's probably some sort of like organic thing that you might find in your body, like a sort of hormone or something like that. Okay.